Okay, guys. So last time we were going through the branching thing, and we were saying like there are like different kind of instruction in that, like jump, call, and compare. Jump is kind of to jump from one line number to another line number or offset. Call is to call any function, and then once the function work has been done, then return to the callee. And then there is a compare function. So compare function, you can ask me a question like why it is related to branching. It's not jumping from one, it is not helping me in jumping from one instruction to another. But the thing is, compare is normally used with in association with any jump instruction, because lot of jump instruction actually sees the flag value, and compare, when you do a comparison between some data or any register, what actually happen, it actually sets some of the flags, and then jump instruction actually sees those flag and then kind of jump to from one offset to another. So this thing will be clear now, and I will be going through a lot of assembly codes. And one of the way I can show you the jumping is basically if I go over here, so you can see the compare instruction is there, and just below that you see a jump instruction, jump if greater than equal to. Okay, so this actually compare function, actually what it does is actually kind of set a zero flag. Okay, if the values are equal, and then kind of jump actually uses a zero flag and then kind of jump from one portion to another. Okay, so even here you can see the compare function is just associated with the jump instruction. Okay, so if you want to see the branching, as I have told, you can press the space key. So let's press that, and you can see the quickly the graph value over here, and you can use this thing to kind of go through the graph thing. Okay, so in the first thing, in the first part, I see like, okay, jump is there, and then it is either going to this block or going to this block. Okay, and similarly the fashion, the same thing is happening in the below part. Okay, so we'll be seeing this all thing in much more detail, but in this it might be clear like how branching is working over here, and a lot of branching are actually dealt with here, which JGE, which is jump greater than equal to. Okay, so let's go forward and kind of let's make those things more clear. Okay, so let's do that. Okay, so the jump is actually of two part. Okay, so one of the thing is it can be either conditional or it can be either unconditional. Okay, so over here in this part, the jump that you are seeing over here, JGE, is actually a conditional, because it is seeing a condition and then jumping. But kind of let's search if there's any instruction which is just the jump. Okay, I'm not getting that now. Okay, so there will be something called as conditional jump, and there will be something called as unconditional jump. Okay, so in the unconditional jump, it will be something like this. I'll just let you know. Okay, so in this instruction code, like line number 1, line number 2, so over here, as you can see in line number 3, there is a jump instruction. Okay, it's not checking any condition. As soon as this thing comes jump 5, it is the execution, the EIP instruction will jump to the 5th instruction, and it won't execute the 4th instruction. So that's how jump work. It doesn't check for any condition. Okay, but the other instruction that I was going through, the conditional jump. Okay, so conditional jump can be of different types, and kind of as you have seen over here too, that it's kind of checking something. The add is doing something, and jump is checking if jump not 0, it is checking a condition, and then it is either jumping to this block, or if not, then it is jumping to this block. Okay, so this is how a jump is actually in assembly instruction. And kind of let's go again further, and to call a function, actually the normal function that we have seen is the call function. I hope this is clear to all of you, that when suppose I'm calling an add function, I will just call add, and the function will jump to that function. The add function will do some of the work, and then it will return back to the callee. Okay, and similarly the ret instruction actually tells that function to now that your work has been done, and now let's return to the callee. So it's also kind of like ret instruction is again something similar to kind of calling the callee function. Okay, at a particular offset. Okay, both the things are doing a jump over here. Okay, even the call is calling something and returning is also calling something, but here call is calling a function like add, subtract. Return is something which is calling back its callee function, okay, to with a particular offset. Okay, and then there is something called as looping, where there are instructions related to kind of implementing a looping, as well as like there are instructions called loop, okay, which helps you in kind of implementing a for loop or while loop. Okay, so these are the overviews, and let's now go in much more detail for all these things. Okay, so conditional jump is also used to implement looping. So as I have told, like suppose kind of I have written a code where uh, I have done something like this. Just let me do it by all right. So suppose I have implemented a loop for I in range 0 comma 5, print hello. Okay, so let's run this, and you can see hello has been printed 4 times over here. So what is happening is there if you see the assembly language of this, so there will be a jump, okay, which is checking if the I value is less than 5. If it is, then it is calling again the same line in the so what is happening is like here in the assembly part, the I value was checked, and if it is kind of less than 5, then there is a jump instruction which kind of again calls the line number 9. Okay, so once the line number 9 is done, then again the I value is checked, and if it is kind of greater than 5, then it is jumping to the 11 instruction. So kind of for this code we will be seeing in much more detail how the assembly kind of language looks like. But similarly things happen where jump instruction is kind of jump with a jump, not just the unconditional, but the conditional jump actually kind of check if I value is less than 5, then it is jumping to the line number 9, else it is kind of jumping to the line number 11. Okay, so let's go forward. Okay, now I want to discuss something over here, which is the arithmetic or Boolean instruction. So what happened, like when I do add EAX and ECX in this instruction, so what will happen is kind of suppose EAX value was 5 and ECX values was 3. So the end result of this whole instruction will be EAX will be set to 8. So the value of EAX will change to from 5 to 8, 5 plus 3. So so thing is there might be a case where you don't want to kind of uh, change the value of the register, but you want to kind of see kind of get the end result. Okay, so what will happen is like in that case actually you need to use certain different instruction like compare and test. So compare is something what it does is actually kind of it is similar to sub instruction, and sub actually means subtraction. So suppose I have written I am subtracting EAX from EDX. So let's see that. So actually what I mean is like suppose you have two instruction over here like sub EAX and compare EAX comma ECX. So what will actually happen is kind of in the first line, suppose the EAX value was 5 and ECX value was suppose 3. So what will happen is the after execution of the first instruction, the EAX value will actually change to 2. Okay, but if you don't want to change the value of EX, but even though you want to get the you want to know the result of the kind of subtraction, like if I want to check if the EX minus ECX give me 0, or if it is giving me something negative, or if it is getting me something positive. Okay, so here the thing is, the final value was a positive value, that is 2. So if I don't execute this instruction sub EAX and ECX, so what will happen is kind of the value will so if I don't execute this instruction, the one over here, so what
But
will
again,
happen?
in that
Yeah,
case, EX is subtracting from sorry, ECX is subtracting from EAX, right? 3 minus 5, right?
no,
Or
no,
else
no.
it,
Yeah, it's EAX minus ECX, and then the value is actually saved into EAX.
okay, fine,
Okay,
okay. But
okay,
I mean, I remember that
okay,
I
yeah.
mean, first source and destination, like the destination will be to the left side and the source will be the right side. So I thought,
Yeah,
yeah,
we will see that. We will verify this, like if it is in this left side or right side format. But thing is, the destination, what I told was destination will be EAX. So the end result will be saved in the EAX. Okay, so that's what I mean. But this
okay,
thing, this comparison, this subtraction thing, we will actually see that in like assembly language, how these values are coming. But overall thing is, whatever will the end result, like suppose it is ECX minus EAX or EX minus ECX, the end result will be always saved in the EX register. Okay.
yeah, fine.
Okay, so now let's suppose like this instruction was not there. Okay, so what will happen, suppose I want to know that if the value of 5 minus 3 is a positive value, or it is a 0, or it is a negative value. So but I don't want to change the value of EX register. Okay, so what I will do is I will use the comparison instruction, and what it will do is actually it will subtract the value EX minus ECX, and then it will actually set the 0 flag. Okay, I think it will set the 0 flag to 1, and what will happen in then the jump instruction that is just below that will actually kind of see this, like the jump 0 flag will actually see if the 0 flag is set, and then it will actually jump to certain instruction, or if not, then it will jump to certain other offset. Okay, so that's how the thing happens, where we don't want to change the value, but we want to see the end result. So that's where we can use the comparison instruction, and there are actually similar instruction like that, a lot more. Okay, so comparison is implied sub, and test is implied and. So and I mean is like suppose kind of there was an instruction called as and EAX comma EAX. Okay, and suppose EAX value was 5, EX value was 5, and then so what will happen now, the EX value will be EAX and EAX. And what I mean from that is, the EAX value, like suppose I write 5 as in binary. So in binary, I think it will be 101, 0101, something like this. Okay, 2 power 0, and then 2 power 0 is 1, and then 2 power 2. So 2 power 4, 2 power 2 is 4, 4 plus 1 is 5. So what it will do, it will AND this thing with, again with 0101. So the answer will be the same thing, 0101. So I hope you guys know about the AND and OR get. So over here, the thing is the value of EX is actually changing. So suppose I am doing something like this, like suppose I am having some value in ECX equal to 4. Okay, and I do over here and EX and ECX. Okay, so what will happen is, just give me a moment. Okay, so now suppose I am doing something instruction like this. Suppose the EX value is 5 and ECX value is 4, and I am doing AND EX comma ECX. So what will happen? The both the instruction value will be saved to the ECX. So the 5 value is 0101, and the 4 value is something as 0100. So now the AND instruction, the value of EX will be changed to 0100. Okay, because of the AND thing, like 1 and 0 will be 0, 0 and 0 will be 0, 1 and 1 will be 1, and 0 and 0 will be 0. So now the value of EAX will change to 4. Okay, now the thing is, I don't want to kind of change the EX value, but I want to kind of understand the final result. So just to like see like, okay, if doing both the EX and EX actually changes the value to suppose 0, something like this. If I just want to check this, but I don't want to change the value of EX, so what I will do is I won't use this function, but I will use this instruction, test EX comma ECX. So this will actually do the same thing, and EX and ECX, but it won't save the final value to the EX, and it will kind of either set the 0 flag to suppose 1, maybe because the end result was not 0, and then the jump instruction will use this value and then kind of jump to any instruction. So I hope this line was clear to all of you. Like if I want to avoid the side effect, we can use certain different instruction to kind of achieve the same thing. I hope it is clear, right?
Yeah, Prakya.
Yeah, okay.
Okay, great. So let's move forward. Okay, now let's kind of analyze the jump instruction in much more detail. Okay, so what is happening, as I've told that the jump instruction is kind of, okay, so as I told, the jump instruction can be actually of different types. Okay, so there are different types of jump instruction. So like one is like so the format, so syntax is actually JCC. Okay, JCC is the format where C can be anything and C then other C can also be other thing. Okay, so just for an example, if I go to this instruction and kind of see this value over here, so as you can see, the jump, conditional jump, is actually having J in the starting letter, and then it is C and C. So here C is not and C is 0. So it actually means jump if not 0. Okay. So that's how the syntax is of any jump, conditional jump instruction. And now let's go over here back. So it is not like you have to use both the C. It can also be JC or it can be J double C. So I can write, so there are instructions like JA, which is jump if above. Then there is JB, which is jump if below. Then there is something called a JE, where it is like jump if equal. Like suppose I'm comparing two variable. Okay. Then JG, which is jump if greater than. And then JL, jump is less than. And JZ, which is jump if 0. So I think this one you have already seen. And then this is like jump if not condition. Okay. Yeah, so jump if not condition. So just a minute. So then there is something called a jump. So suppose jump if not condition. So as I told, that J can also take two values, JCC. So here it is taking two values, J not and 0. So now the instruction is jump if not 0. So actually it will see the flag value of 0 flag, and then if it is like kind of set, then it will like not, it will jump to certain offset. If it is not set, like if the value of 0 flag is 0, then it will jump to certain different offset. So now the JA and JB will be much more clear as I will go down. So the condition associated with jump is evaluated by examining the bits in the flag register. So we actually don't kind of in the jump instruction, normally actually if you see, we don't kind of, just let me go over. So as you can see here, jump not 0, there is nothing that we are doing anything, like we are not telling, okay, compare, see the value of EX or ECX. What happened is jump not 0 will actually, jump instruction by default only checks the flag value, like 0 flag, carry flag, over flag, and something like that. Okay, and it won't kind of deal with any register. It will just deal with the flag value, and the flag value will be modified based on what instruction is above or below, mostly above that instruction. Okay, so let's go over here. So this is how, like I want to let you know that jump only deals with the flag register. Okay, and kind of now let's see what we mean by the jump below and jump above. Okay, so what happened is like jump below is actually true if the carry flag is 1, and jump above is true if both the carry flag and 0 flag is 0. So what will happen is kind of whenever you see an instruction called JB or JA, So what will happen, you need to know that if the carry flag was set to 1 by any of the instruction above, then the this instruction will be set to true. And if this carry flag was 0, then this instruction will be set to false. And similarly for JA, if the carry flag and 0 flag both are set to 0, then this condition will be true. And if this carry flag and 0 flag is not set to true, not set to 1, then it will be false, and then it will jump to certain other instruction. Okay, so we will see this in the example below. Okay, like how this thing will come. And then there is something called JL. So JL is some jump if less than. So this is only true if sign flag is not equal to over flag. So the thing is like, okay, and now I know, okay, that sign flag, this JL will check the sign flag and over flag. Then the JB will check the carry flag. Then JA will check the carry and 0 flag. But we will also see like which are instruction and how, what are the scenarios where this flag value will be set or unset. Okay. So then
Yeah,
there's something, yes.
we have also seen like jump if greater than and equal to
Yes.
JGE.
Yes. Yes.
In that case, I don't think only one criteria will meet. I mean, true if sign flag is not equal to overflow flag. It has to take two values because
Yes. Yeah.
uh, the sign flag and might be zero flag as well.
Yes, correct. Yeah. So what will happen in JE? So it will be true. First thing is it will true that if 0 flag is 0, and then the equal instruction will check if the 0 flag is 1, and plus I need to check it will jump greater than might also see the, I think, the carry flag as well as the 0 flag. Yeah, it won't be depending on just one flag. Okay, so we will see this. What we'll do is kind of before any jump instruction is going to be executed, we will see the 0 flag, what's the value of 0 flag and kind of other flag, and then we'll see how the 0 jump JE actually behaves. Okay, so we'll see that in practical. Okay, so let's move forward. Okay, so this is one of the kind of snap that I just want to showcase you guys, is that in a jump instruction, what will happen? It's an unconditional jump. So it is jumping to location 4018 D9. So 4018 D9 you don't see over here, but it is jumping to that instruction directly from 18C5. It is jumping to 18 D9. Okay, and the conditional jump will look something like this. So over here you see the JZ, the jump if 0, jump if 0, and kind of above that there are instructions called decrease ECX, like decrement the counter of ECX. Suppose the ECX is 5, then the deck ECX will change the value of ECX to 4. Okay, and similarly test EDX and EDX will actually kind of do an AND operation of EDX and EDX, and then if the 0 flag is set, then it will like jump 0 will be kind of true, and then it will jump to certain other offset over here. So I hope in overview this thing is clear, like how the conditional jump looks like and how the unconditional jump look like, right?
Yeah, Pragya. Yeah.
Okay, okay. So we'll see in much more detail actually the question that you arised regarding the 0 flag and the carry flag. We'll see that in much more detail how the things are getting affected with this instruction. Okay, and then we'll see
But
how
again,
the, yes.
one more thing, like if we want to jump from 2 to 50, we will use the jump instruction. Similarly, for vice versa, I mean, from 50 to, I mean, before line, like let us say second line.
Okay.
So, can we use this jump instruction, or else is there any other instruction?
Yeah, so yeah, jump instruction, as you told, like first you need to specify you're talking about the conditional or unconditional. So suppose if you're talking about the unconditional, so definitely it will work. So you might have seen like when you were kind of guys doing the C programming, or I think in the C program there was a statement called go to. Okay.
Yeah, Pragya.
Yeah, so go to doesn't do anything. It's like go, if I tell okay, if the go to is written in line number 5 and I tell okay, jump to go to line number 10, so it will directly jump to line number 10. It won't see what other instructions are. And similarly I can move it back to kind of line number 2. It will happen. And also thing is you can use this even to kind of maybe implement a loop kind of functionality using the jump instruction. But normally, as you might have, if I recall, like in when we are doing the C programming language, it was told like not to use the go to statement because it is a little bit not, it is not complex, and kind of always use kind of try to use the complex instruction like jump zero, jump zero not flag. So it will improve your assembly language or kind of C language writing the code uh, like way. Okay, so obviously you can jump from one offset to another offset in a very easy manner, and there is nothing in the assembly language that will stop you kind of from doing that. Okay, so so now in a 32-bit register, as I told, a 32-bit register can hold 32-bit of value. So if it is an unsigned number, if it is an unsigned, so the range will be from 0 to something like this. Okay, 2 power I think 31, the value is 42494967295. Okay, and if it is unsigned, so can you tell me why the value is changing? If the number is what I mean by unsigned and signed, and why the value is changing? Anyone? Any guess?
Because it has to take minus 2 power, sorry, it has to consider the minus values as well. So
Yeah.
that's why it is dividing. I mean, the total value will be uh, 4 like 4294967 295, even if
Yes.
we compare unsigned and signed. So that is how it is dividing the signed values. Like,
Yes, so exactly. So what is happening is actually, suppose the 32-bit register, and if I'm seeing the 32-bit of that, so the highest bit of that will be actually kind of, suppose I am telling the function, and there's an instruction which I'm telling, okay, treat every number as unsigned. That means treat every number as positive. So what will mean the high bit will be actually free. Okay, everything will be calculated and number range will be 0 to 4294. But when I'm dealing with something number, I'm telling, okay, if it is a negative or if the number is a positive, so what will happen, the number is negative or positive will actually be kind of uh, told by the most highest bit. So if the most highest bit is 0, so that means the number is a positive, and if the highest bit is kind of a 1, that means the number is a negative. Okay, so what happened is now in the 32-bit, one of the highest bit is getting occupied for utilization of signed or unsigned, if it is a positive or negative. So that's why we are only remaining with now with 31-bit. The first bit is the highest bit is used for the negative and positive signature. So that's why the value then it start getting changed. It's from 2 power 147 to 2 power 2147, something like this, because I am now losing one of the bit for checking if the number is a positive or negative. Okay, so that's why actually the range decreases over here. But here, since I have the full 32-bit, the range is actually higher. Okay, great. So now let's see over here. So kind of there will be certain kind of thing that you will encounter where the value is kind of suppose the register value is 0x FFFF, all the things are set, like everything. F means 1111 in binary. Okay, so suppose everything is set. Okay, so you might get confused, okay, if it is a -1 because the highest bit is 1. Okay, or it is everything is in positive value, which is 4.2 billion. Okay, so this thing, to kind of clear those all things, like if this value is treated as kind of signed or unsigned, actually, as I told, you need to understand the context. You need to see the above and below code, how this value is being used, and then you can tell, okay, this number is kind of treated as an unsigned number, and then I will go with the 4.2 billion. Okay, so that will depend on what codes are written above and below of this number that you may be encountering anywhere in the assembly instruction. Okay, so now like what I have done is like previously I told like that I have picked one of the functions and I kind of will be analyzing that. And now actually after completing some of the assembly instruction, now the time has came to kind of see this function in much more detail, what are the assembly instruction and all the things. Okay, and to do that, let's see like what are the things I have for this. Okay, so kind of you need to answer one of the question is, how many conditional jumps are there in this function for 0145E? Okay, so just give me one moment. Okay, guys, just give me 2 minutes, and kind of in the meantime, if you are loading this WinHelp 32, I will want you guys to kind of go to this function sub 40145E and kind of try to answer the question how many conditional jump you are seeing over there. Okay, fine. So I'm just unmuting myself for